Welcome to EMI-BRAIN, your one-stop channel for tutorials that make learning simple, sharp, and successful.
Balancing of chemical reaction. Balancing of chemical reaction. Please write subheading. Balancing of chemical reaction. To balance a chemical reaction, right? To balance a chemical reaction. To balance a chemical reaction. The number of moles of the reactants. The number of moles of the reactants must be equal to the number of moles of the product. The major condition for we to say an equation is balanced is that the mole of the reactant must be equal to what? The mole of the product. Are you getting it now? You know, during chemical reactions, not just the reactant that combines the lot, even the moles also was combined. So in balancing a chemical reaction, the major consideration is that the mole of the reactant must be the same with that of the product. If they're not the same, that means the equation is not what? It's not balanced. So until they are the same, we can say that the equations are what? Are balanced. For example, let's say if I have hydrogen plus what? Oxygen. What is the product here? Water. Whenever this combine with this, whenever hydrogen combine with oxygen, what's the product? Is water. But the mole of hydrogen here is what? 2. What about here? It's 2. So it's balanced, right? But let's check for oxygen. What do you have here for oxygen? 2. What do you have here? Is 1. So what we do is to have to add what here? 2 more here to balance what? Oxygen. But by adding 2, I've increased hydrogen by what? By 4. But here's what? 2. So what do we do here? I will add 2 here. Is it also? Now what do we have? We have 4 moles of hydrogen. 4 moles of what? Hydrogen. Here we have how many moles of oxygen? 2 moles. Here's what? 2 moles. So it's balanced. So the mole of the reactant equals what? Mole of what? The product. So this is balance. Are you getting it now? But we call this method. Okay, let's go, right? Method used in balancing a chemical equation. Methods used in balancing a chemical equation or chemical reaction. Methods used in balancing a chemical equation. Method used in balancing a chemical equation. Number 1, by observation. 1, by observation. Number 2, by mathematical method. Mathematical method or algebraic method. Number 3, we have the reduction and oxidation method. Reduction and what? Oxidation what? Method. But basically, we have 2. We have by observation, we have what? By mathematical what? Method. There is some other materials we have called reduction and what? Oxidation method. Are you there? This is basically for redox reactions. Are you there? But let's look at by mathematical method. What I will be emphasizing on will be on what? Mathematical what method. What I just did now is by what? Observation. I observed the mole of what? Of hydrogen and what? Hydrogen on this side and balance them up. But most of the times, by observation is limited. Is what? Is limited. There are some complex chemical reactions that we cannot observe. No matter how good you are in chemistry, you have to apply what? Mathematical what? Method. Are you getting it now? So I'll be teaching us basically on what? Mathematical method using balancing what? The chemical equation. Are we ready? Okay? Are we ready? Okay. Mathematical method. Mathematical approach. Okay. Let's look at some equation. For example, let's go back to that first example we solved using observation method. For example, if we are given this, example 1, if we are given H2 plus what? O2 What's the product here? H2O, right? And we have to balance using what? Mathematical what? Method. Either. Now, the first thing we need to do is to assign an alphabet to each of these species here. I will assign here to be what? A. Here to be what? B. Here to be what? C. I'll just assign alphabet to represent the modes. Either I will say let's A, B, and what? C. Now, why am I using A, B, C? Because we only have how many species here? 3 species. Either. So let A, B, C represent the modes of the species. So what will be here? A, H2, right? Plus what? B, O2. What will be here? C, H2O. Then after this, I will bring out my table. In the table, we have what we call the elements. Here we have number of mole of the reactant. And we have number of mole of what? The product. What are the elements we have here? The elements we have here. We have hydrogen, right? We have what? Oxygen. That is all. These are just the 2 elements we have. Are you getting it? Because the same element we have here and the same we have here. Are you getting the concept? Okay. So now the number of mole of reactants for hydrogen is what? In the reactants here, what's hydrogen mole? 2, right? So I multiply this 2 by A. What do you have here? 2A. 2 times A is what? Is 2A. Number of mole of this for the reactant space. This for the product space. So for hydrogen in the reactant is 2. 2 times A will give us what? 2A. Now let's go to oxygen in the reactant. How many do we have here? 2. 2 times B is what? 2B. Are you getting it here? Then for the product side, what's the mole of hydrogen in the product side? Still 2. 2 times C is what? 2 what? 2C. Now what about oxygen in the product side? 1. 1 times C is what? C. Are you getting it here? Now what's the condition for a reaction to be balanced? What's the condition I gave you? The mole of the reactant must be equal to mole of what? The product. Right there? Then we say that we call the mole of the reactant must be equal to mole of what? Mole of what? The product. Mole of the product. Number of mole of the reactant must be equal to that of what? The product. Now what are the reactants here? That means 2A is equal to what? 2C. 2B is equal to what? C. So here we have that 2A is equal to what? 2C. What again? 2B is equal to what? C. Are you getting the gist here? Now, look at this. In this case here, in the reaction, what is the mole of hydrogen here? What does A represent here? 1. Are you getting it? So I can assume A as 1. Once you bring out this equation 1, this equation what? 2. Just say let A equals to what? 1. Because your A value is what? Is 1. Are you getting it? So if A is 1, can I put that 1 into equation 1? I will say put A equals to 1 in equation what? 1. That will give us what? 2 times 1, right? Equals to what? 2C. What is 2 times 1? 2 equals to what? 2C. Now, if we have this in mathematics, for we to solve for what? For C, what do we do? We divide both sides by what? By 2, right? For me to eliminate, to solve for C, I have to look for a means to eliminate these 2, right? So I will say divide both sides by what? By 2. By what? By 2. So 2 can go with 2, right? 2 can go with what? 2. What's our C here? C is what? 1. Now we have gotten C as 1. Also in equation 2, what do we have? 2B equals to what? C. What's our C? 1. Now I can say put what? Put C equals to what? 1 in equation what? Equation 2. And what's equation 2 saying? 2B is equals to what? C, right? So we have 2B equals to what? 1. Are you there? Are you following? Now how do we solve for B? But we start by what? By 2. Divide both sides, right? Divide both sides by 2. Let me write here. Okay, let me finish up here. What do you have here? 2B over 2, right? Equals to what? 1 over 2. Can 2 go with 2? What's that B? B is what? 1 over what? 2. Therefore, A ratio B ratio what? C. What's that A? 1. Is A 1? Yes. What's that B? 1 over 2. What's that C? 1. You know, it is not proper using half as a mole. I can't just come here and put 1 here and put half here. Are you getting the gist here? So what do? I'll look for a means to eliminate what? These 2. So what will I do? You can tell me. How will I remove these 2 from here? What is LCM between? No, this is like saying 1 over 1, Abi. This is also what? 1 over 1. What's the LCM here? Is 2, right? LCM between 1 to 1 is 2. So I will say multiply 2 by what? By 2. So when you multiply 2 by 2, 2 will now cancel what? 2. Is that not? That will give us what here? I will say multiply 2 by what? By 2. So that will give us, let's go, A ratio B ratio what? C. What will be here? 2 times 1 over 1, Abi. What will be here? 2 times 1 over 2. What will be here? 2 times 1 over 1. This will give us what? 2, right? 2 can cancel 2, right? What's many as what? 1. 2 can cancel, so 1 over 1. So that will give us what? 2, right? Thank you. So we have 2 times 1 over 1 will give us 2. Therefore, what do you have here? Recall. What do you have here? Bring out this question for me. What do you have? A, H2 plus what? O2, giving us what? CH2O. What's that A? So 2H2 plus, what's that B? 1. That is O2, right? What's that C? 2 what? H2O. Are you getting it now? Is it balanced? It's balanced. Mole of hydrogen is what? 4. Here is what? 4. What do you have here? 2. What do you have here? 2. So it's balanced. Is that clear? Okay, number 2, balance this equation. CH4 plus O2, giving us CO2 plus what? Water. So here we have 4 species. 4 species. So to solve this, to balance rather, we're going to say let what? A, B, C, and what now? D. Represents the moles, right? Moles of what? Of the species. In other words, here becomes what? ACH4, right? Plus what? BO2, giving us what? C, CO2 plus what? D, H2O. Then the next is that we're going to create what here? Our table, right? What do you have in the table? Element. Here's what? Mole of reactants. Number of mole of reactants and number of mole of what? Of product. Let's list out the elements we have. We have carbon, Abi. We have hydrogen, and we have what? Oxygen. Number of mole of reactant for carbon is what? In the reactant space, we have this, Abi. This is the what? Product space, is it not? So carbon is what? Here, 1. 1 times A is what? Is A. What about hydrogen? 4. 4 times A is what? 4A. Are you following? What about oxygen? 2, right? 2 times B is what? 2B. Now, in the product side, carbon is 1 in the product side. Still 1, right? 1 times C is what? Is C. What about hydrogen? 2, right? 2 times D is what? 2D. What about oxygen in the product space? Oxygen also appears here. How many more do we have here? 2, Abi. How many more do we have here? I won't say 2 plus 3, no. Because the mole of this is different from the mole of this. Mole of this is what? Is D. Mole of this is what? Is C. So here we have 2, right? 2 times C is what? Here will be 2C plus. There's a plus sign here. What the mole of oxygen here? 1 times D is what? D. Are you there? So what's the condition to balance the chemical reaction? What's the condition? Condition is what? The mole of the reactant must be equal to what? That of the product, right? Meaning that A must be equal to what? C, equation 1. Are you there? Also, 4A must be equal to what? 2D. 4A is equal to what? 2D. Equation what? 2. Also, 2B must be equal to what? 2C plus what? D. Equation what? 3. What the first condition I said? So let A equals to 1. All the time. Your A is always what here? 1. So I'll say let A equals to 1. If A is 1, what happened to C? C is also what? 1. Are you getting it now? If I'm saying let A be 1, if my A is 1, that means my C equals to what? 1. That means here, also C is what? 1. If A equals to 1, can we solve for D? Huh? So I will say put what? Put A equals to 1 in equation what? 2. Equation 2 says what? 4A equals to what? 2D. So we have 4 times 1 equals to 2D. So how do we solve for D? You can tell me. 4 times 1 is 4, right? Equals 2D. So I'll divide both sides by what? Divide both sides by what? By 2. That will give us 4 over 2 equals to what? 2D over what? 2. 2 can go with 2, right? 2 here 1, 2 here is what? 2. That means that our D is equals to 2. Is that not? Okay, so if D is 2, let's solve for what now? B. Do we have our C as 1? What's our D? 2. So what do? We say put C equals to what? 1 and what? D, thank you, equals to what? 2 in equation what? Equation what? 3. Equation 3 says what there? 2B equals to what? 2C plus what? D. So can we substitute the value now? So we have 2B equals to 2 times, what's that C there? 1 plus D is what? 2. Are you there? So this will give us what? 2B is equals to what? 2 plus what? 2. So 2B is equals to 4. Are you there? Now what we do next to solve for B? Divide both sides by what? 2. Thank you. Divide both sides by what? By 2. That will give us 2B equals to 4 over 2 over what? 2. Are you there? So here we have 2, we cancel 2, right? So what's that B? 2, because 2 here 1, 2 in 4 is what? Is 2. Therefore, A ratio B ratio C, right? Ratio what? D. What's that A? 1. What's that B? 2. What's that C? 1. What's that D? 2. In this case, there's no fraction. This makes the work easy. I won't start saying let's multiply through by any factor here. Because all of them are what? Whole number. Are you there? Therefore, let's put the value here. What's that A? 1 and B. So we have C, H4. What's that B? So we have 2 what? O2. Sorry. What's the product here? What's that C? 1, which is what? CO2. What's that D? D is what? 2 what? H2O. Let's check if it's balanced. Carbon is what? 1. Carbon is what here? 1. Mole of carbon is 1, 1. What's mole of hydrogen? 4. What about here? It's 4. What's mole of oxygen? 4. What about here? 2 plus 2, Abi, making it what? 4. So is this balanced? Balanced. Yes. So you can put this out. We have to balance this. So we're going to select what? A, B, right? C and D represent what? Moles of what? The species, right? Here becomes what? AC3, H8 plus what? BO2. You have C, CO2 plus what? D, H2O. Then we create our table, is that not? Okay, what will be here? Elements. Our elements are what? Carbon, hydrogen, oxygen, right? Here we have number of moles of what? Reactant and that of what? Product. What's the number of mole of carbon in the reactant? 3. 3 times A is what? 3A. What of hydrogen? 8. 8 times A is what? 8A. What of oxygen? 2. 2 times B is what? 2B. Now for the product side, what's carbon? 1. 1 times C is what? C. What of hydrogen? 2. Which is what? 2D, right? Now for oxygen, we have what here? We have 2C plus what? Plus D. Is that not? Then we're going to say that recall the number of mole of what? Reactant equals what? That of product. Meaning 3A is equals to what? C, equation 1, right? Also, 8A is equals to what? 2D, equation what? 2. Also, 2B is equals to what? 2C plus D, equation what? 3. Are you getting it now? Now, what's the first thing we say? What's the first assumption? From here, our A is 1, right? So select what? A equals to 1. If A equals to 1, that means my C is what? 3. If I'm saying A is 1, what is 3 times 1? 3. So C equals to what? 3. So yeah, our C is equals to what? 3. Is that clear? Now, if A equals to 1, can we solve for D? So I'll say put what? A equals to 1 in equation what? 2. I'll say put A equals to 1 in what? Equation what? 3. And that will give us what? 8a equals to what? 2d. So 8 times 1 equals to what? 2d, right? So what do we do to solve for d? We divide, right? Both sides by what? By 2. 8 times 1 is what? Is 8. Equals to 2d. Over what? 2 over what? 2. So that means our d is what? 4. Now we have gotten value of d. We have gotten value of what? Of c. Let's solve for what? b. So we say put what? Put c equals to what? 3. And what? And d equals to what? 4. In what? Equation 3, right? And 3 says what? 2b equals to 2c plus what? D. So we have 2b equals to 2 times. What's that c? 3. What's that d? 4. Are you getting it? Are you there? So what do you have in? What's the next thing? What's the next? 2b equals to what? 2 times 3 is 6. 6 plus 4 is what? 10. So here will be what? 10. So let me solve for our b. We divide, right? Both sides by what? By 2. That will give us 2b equals to 10 over 2 over what? 2. So what do you have here? B is equals to what? B equals to 5. Exactly. So here we have A ratio, B ratio, C ratio, what? D. What's that A? 1. What's that B? 5. What's that C? What's that C? 3. What's that D? 4. Exactly. So let's impute our value. So let's just put the value here direct. Are you getting this? Let's see the balance equation from here. So A is 1. B is what? 5. What's that C? 3. What's that D? 4. Exactly. Let's check. Carbon is 3 here. Carbon is 3. What's hydrogen here? 8. Yes, 8. 4 times 2 is 8. What of oxygen? 10. Here we have what here? 6. Right? 6 plus 1, 4, making it 1, 10. So this is balance equation. Exactly.